Good day, MT1. Welcome to Module 3 of the MTChem 1 lecture. I am Miss Angela J. Lozano, your module writer for Module 3. And I will be discussing about chemical reactions, calculations, and solutions. Let's take a look at the outline for Module 3. As you can see, there are a lot of topics to be covered in this module. First, we will be discussing about chemical equations, with the subtopics writing and balancing chemical equations and the different types of chemical reactions. We'll also be discussing about chemical calculations, wherein you'll be dealing with a lot of numbers and solvings. Subtopics are measurements in chemistry, significant numbers, rounding off numbers, scientific notation, formula mass, and mole. And under mole, we will be focusing specifically about molar mass and Avogadro's number. We will also be discussing about solutions, its definition and characteristics, the general properties of solution, solubility and its rules, molarity and concentration and dilution. Some of these topics, subtopics, have solving involved in them. Okay? As you can see, there are a lot of topics to be covered in Module 3 lecture, but please do not be overwhelmed with them. During the discussion, I will be dividing the topics so that you are able to take breaks in between. Here are the materials that you need to prepare in order for us to have a smooth discussion and for you to follow through the discussion smoothly. Of course, you need to prepare pen and pencil, whichever you prefer. You also need to prepare your own scratch papers or lecture notebooks for you to take down notes of the important concepts that will be discussed and also for you to participate in the solving part. You'll also be needing a periodic table. Again, the periodic table that you need to use is uniform so that we can have the same values whenever we are discussing. It's already posted in the module. And we also need a scientific calculator. As mentioned during the discussion of the outline, there are a lot of solving involved in Module 3. Please make sure that you know how to use your scientific calculator, you're very familiar with it. And if you're not, kindly ask help to someone who knows how to use a scientific calculator. Okay, maybe it's your senior, your classmate, or your brothers or sisters. Okay? Let's now start with the part 1 of the Module 3, which is chemical equations. Again, under chemical equations, we have the subtopics, writing and balancing chemical equations, and the different types of chemical reactions. So at the end of this lecture, here are your objectives. You should be able to write and classify chemical equations properly, balance different chemical equations correctly, and differentiate types of chemical reactions and solutions. So we'll be going back to these objectives by the end of the discussion to make sure that we achieve these objectives. Let's start first with the subtopic 1, which is writing and balancing chemical equations. First, what is a chemical equation? Let's define it first. Chemical equation, it's a written statement that uses chemical symbols and chemical formulas instead of words to describe the changes that occur in a chemical reaction. So it says here, it uses chemical symbols and chemical formulas, okay, instead of words. Okay. How does it look like? Let's take a look at this one. This is an example of a chemical equation. As you can see, there are a lot of chemical symbols and formulas, like a mixture of element symbols and numbers, okay? And they describe the changes that occur in a chemical reaction. Okay? Here are different compounds and elements that interact with each other, and you can see their possible outcome. So what is the use of writing chemical equations? Okay? you are a chemist and you are to describe a chemical reaction, if you were to use words, it might take you a longer time to write it. Let's say, for example, this one. CH4 and oxygen will turn to carbon dioxide and water. So if you were to write it, it might take you a lot of time. Okay? So chemical equations allows us, okay, it allows us to have a shortcut method to write these chemical reactions that we are referring to. Okay? It also allows us to visualize these different compounds and different compounds and different elements. Let's say, for example, upon just seeing methane, you can't immediately visualize it. But if you are to put CH4, you know that there is one carbon attached to four hydrogen. Okay, you can immediately know, you immediately imagine which compound and which element is being referred to. That is the convenience of using chemical equations. Okay, next. Now, here is another example of a chemical equation. We have here zinc sulfide plus oxygen will, will produce zinc oxide and sulfur dioxide. Okay. Now, you might be asking, there are numbers included in this, but I did not read them. So what are these numbers that we are referring to? We'll be discussing that later. But first, let's discuss the different components of a chemical equation. So first, on the left side of the equation, we have what we call the reactants. These are the starting material of a chemical reaction that undergoes change. That means that during a chemical reaction or during an experiment, these are the types that you immediately use. These are the chemicals that you primarily use. Okay, they are the reactants. These are the compounds that you combine to see if they would react or if there would be a change. Okay? On the right side of the equation are what we call products. These are substances that are produced as a result of a chemical change. So combining the reactants, we will be having products. Okay? From the name itself, these are what is produced during an experiment or during a chemical reaction. Now, how do we figure out which is the left side and which is the right side? What is the indicator? The indicator there would be this arrow sign. Okay, this indicates to produce. So upon mixing these reactants, upon combining them with each other, they will produce, okay, they are bound to produce these products. Okay, we also have this sign. We also have this plus sign, as you can see, indicated in both the reactants or the products. This just means, for the reactant side, it means will react. And then for the product side, it can be read as end. So this, if you were to read it, it will be zinc sulfide will react with oxygen to produce zinc oxide and sulfur dioxide. That is how you read it. Later on, we'll be delving much further into that particular topic. Now, let's go back to the numbers that we are referring to in this equation. Okay. So we have these big numbers before the element or before the compound. These are what we call the coefficient. Right? And then the small letters after the compound or after the element, these are what we call the subscript. Okay? Later on, this will be very useful during balancing equations. Okay? Subscripts, they tell us how many atoms are we referring to in this equation. Okay? Let's say, for example, in this compound, there are 2 oxygen. Okay? In this compound, there are 2 oxygen. But this coefficient indicates that there are 2 sulfur dioxide. Okay, so this number, the coefficient, will be referring to both the sulfur and the oxygen, but this subscript is only referring to the oxygen. Okay? Okay, we have these reminders for the chemical equations. So first, let's just reiterate. Reactants are placed on the left side of the reaction. Again, this is our indicator, the arrow sign. On the left side, we have the reactants. Okay? And then on the right side, we have what we call the products. Okay? The arrow sign denotes to produce. Yes, to produce. And the plus sign, okay, denotes separation of reactants or products. So when the reactant side, it can be read as will react with. On the product side, it can be read as N, simply as N. Or you can also put N here. So will react with or N. Okay. Next, the reactants and the products, whether they are compounds or elements, they must be consistent with the experimental facts. Okay? That means, let's say for example, this one, there are what we call monatomic elements, which are helium, neon, argon, xenon, and krypton, or what we call the noble gases. This exists singularly, meaning they only exist in one molecule. Okay? There are also what we call the diatomic molecules. That means they cannot exist on their own. They has to have a pair. So we have here hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. Take a look at this one. Okay, they have to exist in pairs. This is an oxygen element. It's not a compound just like this one. So it needs to exist in its diatomic form. For you to be familiarized much further with this one, kindly remember that diatomic molecules ends with gen, like hydrogen, oxygen, and nitrogen, while the others ends with in. Fluorine, chlorine, bromine, iodine. Okay? There are also what we call the tetraatomic molecules, just like the tetraphosphorus and arsenic tetramer. Okay? Similar with diatomic, they need to exist in four atoms, okay, or four molecules in order to be present. Okay? Now, let's try to write this chemical equation, okay, this chemical equation into words. Okay? Because as we've said, chemical equations are like a convenient way to write, okay, chemical reactions, but let's try to write them into words. So first we have this one. Ignoring the coefficients, we have here zinc sulfide reacts with, will react or end. Zinc sulfide reacts with oxygen to produce zinc oxide and sulfur dioxide. Okay, that's how you write the chemical equations in words. Okay, again, do not forget that you also need to read this plus sign and this arrow sign. Okay, now let's proceed with balancing equation. How do we know if an equation is balanced or not? First, you need to make a table. Okay, this is just a suggestion, an easy way for you to visualize balancing equation? First, you need to make a table of reactants and their products, okay, a separate one. And then make sure to list down the elements that are involved in both the reactant side and the product side. So we have here on the reactant side, we have here zinc, we have here sulfur and oxygen. We have them here. And then on the product side are just the same because this only involves chemical reaction. So we have here zinc, sulfur and oxygen. Okay. Following that, you need now to identify how many zinc or how many elements are involved in the reactant side and how many are involved in the product side. Let's take a look at this one. Let's start with the reactant side. How many zinc are included in the reactant side? Again, as I've mentioned a while ago, coefficients indicates the quantity of the whole compound. So what you need to do is that you only need to distribute it to both of the elements involved in this compound. So we have here 2 zinc sulfide. So that means you have 2 atoms of zinc. Right? Proceeding with sulfur with the same method, we have now 2 sulfur. Okay? And then we have here the oxygen. Oxygen has 2 numbers attached to it. We have the coefficient, which is the number 3, and the subscript, which is number 2. So what you need to do here is that you multiply the 2 numbers. Okay? You need to multiply them. So that simply means 3 times 2 is 6. That means you have 6 atoms of oxygen. Okay, so again, for zinc, you have 2 atoms of zinc, 2 atoms of sulfur, and 6 molecules of oxygen. Now, let's proceed with the product side. Similar to what you did with the reactant side, you also need to distribute this coefficient with the compound. So there would be 2 zinc and 2 oxygen. Okay? And then you proceed with the other product. In this one, there is a compound with a subscript, okay, and there's also a coefficient. What you need to do here is you still need to distribute the coefficient to both of the elements, okay. So you have to multiply this one. So you have 2 sulfur. And then you have here, again, as I've mentioned, multiply the coefficient with the subscript. Since the subscript is only beside oxygen, you only need to multiply it for oxygen. So this is 2 times 2, that's 4. Okay? What you need to do now is that you need to add 4 in this one. Okay? Since both oxygens, even though they are in different compounds, they are still under the product side. You still need to combine them just for counting or balancing purposes. So you have a total of 6 oxygen for the product side. Let's now check if it's balanced or not. Okay. So for the reactant and the product side, we have here for zinc, you have 2 zinc for the reactant side, and then you have 2 zinc for the product side. So this one are balanced. For the sulfur, you have 2 sulfur on the reactant side and then 2 sulfur for the product side, indicating that they are again balanced. Okay? Let's proceed now with oxygen. Oxygen on the reactant side has 6 oxygen or 6 molecules. On the product side, there are also 6 oxygen. So this is also balanced. Okay? Looking at our tables, the reactant side and the product side both have balance in all of the 3 elements, meaning this equation is now balanced. Okay? This is now balanced. Again, if the reactant side and the product side have the same amount of numbers with the different elements that it contains, then we can consider that the element or the chemical equation is balanced. Okay? Just to discuss further in balancing equations, equations that has the same value of atoms on each element involved in the reaction on each side of the equation. This is what we call a balanced equation, just like what we did a while ago. This indicates that atoms are neither destroyed nor created, or atoms are neither created nor destroyed, following the law of conservation of mass. Let's take a look at this one. As you can see, even though there is a chemical reaction that occurred in the reactant side, we still have the same kind, okay, of elements. Okay, we also still have the same number of atoms per element. So again, we have here 2, 2, 6, 2, 2, and 6. Okay, this means that even though there is a chemical reaction that occurred between the reactants and the product side, nothing is created, nothing new is created, and nothing is destroyed. Okay, nothing was added in the product side. Nothing was also subtracted. That means it's the same amount and the same kind of elements that are involved during the chemical reaction. That is what we mean when we say atoms are neither created nor destroyed. Same number of atoms on each element. Okay? Now, how do we balance chemical equations? Let's have more practices in order for us to familiarize ourselves better with balancing equations. Let's try to balance this chemical reaction or chemical equation that is given. So again, as you can see, it's in form of words. Okay, but just by looking at it, you can already see that you cannot imagine it or you cannot visualize it, and it seems a little overwhelming because of the words that you need to read. Let's try to make it in a chemical equation form. Okay. So we have here first we have the calcium sulfide. This is calcium sulfide reacts with, again, this will be the plus sign, water, which is simply H2O. Okay, to produce, remember our indicators. Okay, so to produce indicates the arrow sign, which means we are already transitioning from the reactants to the product side. Okay, to produce, we have here calcium oxide and hydrogen sulfide. And for hydrogen sulfide, again, and indicates plus sign, so we have and hydrogen sulfide. Okay. Now, again, first step of balancing equations is you have to identify. Okay, you have to identify which is the reactant and which is the product side. So again, we have here the reactant side, and then we have here the product side. Sorry, we have the product side. Okay, and then we will now list down the elements that are involved in each side. So for this one, first we have calcium, we also have sulfur, we have hydrogen, and we have oxygen. Okay, since they are diatomic, we'll be putting subscript 2 for each subscript for each of them. Now, to the reactant side, we have here calcium, we have here oxygen, anahin na lang natin, ipantay. Oxygen, we also have the hydrogen, and then we have also the sulfur. And as you can see, following the law of conservation of mass, we have the same type of elements involved. Okay? After listing down the elements, we will now proceed with counting how many atoms of each element are there in the reactant side and in the product side. Okay, start first with the reactant side. For calcium, you have here one. Okay, you only have one element for calcium. For sulfur, you only also have one. For hydrogen, there is a subscript of 2, meaning you multiply it with hydrogen, which is indicates that there are 2. And then for oxygen, you only have 1. Okay, you might be confused now, why is there in our list you put a subscript of 2? Again, oxygen, hydrogen, okay, nitrogen, they are diatomic, meaning when you write them, you have to put the indicator, the subscript indicator that they are diatomic, even if in the equation they simply exist as 1. Okay? Is it not diatomic in this one, ma'am, because there is oxygen? No. Okay, because it is in a compound. Okay? If it's simply calcium sulfide plus oxygen, then that's the time wherein you have to put the subscript 2. Okay, because oxygen uh, has no other element to bond with. Okay? So again, we only have one calcium for the reactant side, one sulfur, two hydrogen, and one oxygen. Okay? Let's now proceed with the product side. For the product side, we have one calcium. We also have one sulfur. For hydrogen, we have two because of the subscript. And then for oxygen, we also have one. Okay? Again, we don't have subscript here because oxygen is in a compound. Okay? It's involved in a compound. Let's now check if both of the of if all of the compounds or all of the elements in the reactant side and in the product side are balanced. Okay? Let's check first for calcium. Under the reactant side, we have one calcium. Also on the product side, we also have one calcium. So the check mark on that. On the reactant side, we have one sulfur. On the product side, we also have one sulfur, indicating that sulfur is balanced on both sides. For the reactant side, we have two hydrogen. For the product side, we also have two hydrogen, indicating that we have balanced hydrogen. And last one, for the reactant side, we have one oxygen. And then on the product side, we also have one oxygen. And just by looking at this list or table that we did, you can already see that this chemical equation of calcium sulfide reacts with water to produce calcium oxide and hydrogen sulfide. This one is balanced. Okay? Because again, all of the elements have the same amount on the reactant and the product side. Okay? Hopefully you get it now. Next, we have this equation. Again, it's in word form, so we need to transform it into a chemical equation. So we have here hydrochloric acid combined with sodium hydroxide to form water and salt. Okay? So let's write it into a chemical equation first. So we have the hydrochloric acid or the HCl. Have here the HCl combined with, so when you say combined with, you simply add them. Okay, so there's the plus sign. Combined with sodium dioxide, sodium hydroxide. We have here another example. So as you can see, it's again in word form and we need to transform it into a chemical equation. So we have here hydrochloric acid combined with sodium hydroxide to form water and salt. So first, hydrochloric acid, that's HCl, Combined with, so when you say combined with, this is simply indicates the plus sign. Okay? Sodium hydroxide is NaOH. To form or to produce, okay, this indicates the arrow sign. Okay? Indicates the transition from the reactant side to the product side. So we have here to form water, which is H2O, and that indicates the plus sign, and salt, which is NaCl. Okay, so we have now our chemical equation. Okay, and then again, we will now proceed with identifying what are the elements in the reactant side and the product side. So we have here again the reactant side and the, the product side. Okay, so let's start first with the reactant side. So we have here hydrogen, chlorine, we have here sodium, and we also have oxygen. Okay, for the product side, we have hydrogen, also have oxygen, sodium, and we also have chlorine. And then after this one, let's proceed with counting how many atoms or how many molecules does each of the element have. Starting first with the reactant side, so how many elements or how many hydrogen do we have in the reactant side? So we have here one, and then we also have in the other compound two. So we have two hydrogen in this one. Okay, how about chlorine? Looking at both of the compounds in the reactant side, we only have one chlorine. And that's the same for sodium. We also have one sodium and also one oxygen. Okay, let's double check. We have two hydrogen, one chlorine, one sodium, and also one oxygen. Now, how about the product side? How many hydrogen do we have? You can see the subscript in this one, meaning we have two hydrogen. Then for chlorine, we have one. For sodium, we also have one. And then for oxygen, we also have one molecule of oxygen. Let's now check if the equation is balanced or not by simply looking and comparing the number of atoms for each of the elements. Starting with the hydrogen on the reactant side, we have two. On the product side, we also have two hydrogen, indicating that the number of hydrogen in both sides are balanced. Let's now proceed with chlorine. For the reactant side, we have one. And then for the product side, we also have one. And then continuing to sodium, we have one molecule of sodium. For the reactant side, we also have one molecule of sodium for the product side. Next, oxygen. We have one molecule for oxygen on the reactant side and one molecule for the product side. Okay? Simply looking at all of these check marks, we can indicate that this chemical equation is now a balanced equation. Okay? Again, you simply need to check the number of elements for each side, okay, to see if they are the same or if they are balanced. Let's now proceed with the next example. As you can see in this one, it's already in the chemical equation form. Okay, but let's try to put it into words. Okay, the opposite one. So we have here H2O2, or what we call the hydrogen. This is what we call the hydrogen peroxide. Okay, or what we all know as the agrooxygenate. Okay, will produce of course water and oxygen. And then you can see here, since oxygen has nothing to pair with, or it's not inside a compound, it's just an element. Since it's diatomic, it has to have the subscript 2. Okay? Next, let's list down the type of element and the number of elements for each of the sides. So we have here the reactant side, and we have here the product side. For the reactant side, we have hydrogen and oxygen. That's the same with the product side. We also have hydrogen and oxygen. Okay? Now let's write how many hydrogen and how many oxygen do we have in both the reactant side and the product side. So for the reactant side, we have here 2 hydrogen because of their subscript, and we also have 2 oxygen. For the product side, on the other hand, we have 2 hydrogen, and then we have here 1 oxygen and 2 oxygen in here. So you have to add those. So 1 plus 2, that's 3 oxygen. And as you can see, hydrogen are balanced. We have 2 hydrogen atoms on the reactant side and then 2 hydrogen atoms on the product side. But oxygen is not. We have 2 atoms on the reactant side, but 3 products on the, 3 oxygen on the product side. In times like this, you now need to proceed with balancing equations. Okay? In balancing equations, you need to continuously add, okay, hydrogen. What is the missing out? For this time, the one that's making it in balance is the oxygen. So you need to add oxygen on the reactant side for them to be balanced. Okay, this is a process of trial and error. So let's try to add here 2. Okay, so you now need to transform. Okay, so you now need to change the number that are included here. So hydrogen is now 4 because you need to multiply the coefficient 2 with subscript 2. So this is now 4. And then for this one, you also have 4 because you have to multiply it with the coefficient 2. Okay. Now, as you can see, they did not balance again. Okay. Hydrogen for the reactant side is now 4, while the product side is 2. For the reactant side for oxygen, it has 4, while the product side only has 3. What you need to adjust now will be the product side. Let's take a look at this one. Let's add. In order to increase both of them, we will be increasing both hydrogen and oxygen. We'll be adding 2 in this water compound or water molecule. Okay? Let's try to input their new amount. So for hydrogen, we now have 4. Okay? And then for oxygen, you need to multiply it to this one. So you have 2 oxygen in this compound, and then you also have 2 oxygen in this diatomic molecule. So you simply need to add them. So 2 plus 2 is simply 4. Okay, let's now check. On the reactant side, we have hydrogen, which are 4. On the product side, there are also 4 hydrogen molecules. So these are balanced. Let's take a look at the next one. For the oxygen for the oxygen on the reactant side, we have 4 molecules. On the product side, we also have 4 molecules, indicating that this equation is now balanced. Okay, so your final equation now will be 2 hydrogen peroxide will produce 2 molecules of water and oxygen. Okay, don't forget to put 2 in this area. just to emphasize it, change the color. Also have to put, two. Yes. Okay. Let's proceed with another example. For this one, For this one, you kindly pause, try to answer it on your own. First, you have to write, okay, first you have to write the full name, okay, this equation into words, and then list down the chemicals, or I mean, list down the elements in the reactant side and list down the elements on the product side. And then proceed with identifying the number of elements, okay, in each side, and then take a look if it's balanced or not. Again, kindly pause the video and then try to balance it on your own. Okay, assuming you're done with solving it on your own, let's try to solve it, okay, or balance it together. So we have here ferrous iodide. Again, let's try to put it into words first. So we have here ferrous iodide and chlorine, which is again a diatomic molecule, okay, to produce, sorry, okay, ferrous iodide and chlorine to produce. So we have here FeCl3, that's ferric chloride, to produce ferric chloride and iodine. Okay? So let's now proceed with listing down the elements for each of the sides. So we have again the reactant side and the product side. So we have here the reactant side and product side. Okay? For the reactant side, we have iron, iodine, and chlorine. Okay? Next, for the product side, we have again iron, iodine, and chlorine. Okay? Now let's try to list down. Let's list down now the number of elements for each side. For iron, we have one atom. For the reactant side, for iodine we have two, and then for chlorine we also have two. On the product side, we have one atom for iron. We also have two. We have two atoms for iodine, and then for chlorine we now have three. After listing down the number of elements for each side, let's take a look at if they are balanced or not. Let's take a look at for iron in both the reactant and the product side. So both of them have one atom or molecule. For iodine, both of them have two, but this is where it becomes unbalanced at chlorine atoms. On the reactant side, we have two chlorine atoms, and then on the product side, we have three, making the equation imbalanced or not balanced. So what do we do now, just like what we did a while ago, is that we need to put coefficients in the reactant side because this is the one that's lacking. You cannot subtract, you can only add and add. So let's try to put 2 in this one, making chlorine 4. Okay, making chlorines count into 4. Okay, but still it's not balanced. Okay, because reactant side has now 4 atoms of chlorine, while the product side has 3 atoms. Okay, what we need to do now is we have to increase this other side. Okay, we have to increase the product side. on where chlorine is. Okay, so let's put here again 2. Let's put 2 in this compound. So we have now 2 ferric chloride. So let's change the number. So now we have 2. So now we have 2 iron, and then we have again, okay, and then we have 6. Okay. Is it balanced? Looking at it, it's not balanced. Not only chlorine is not balanced, it's iod. This is also not balanced. Iron is also not balanced. Okay, so we have to balance iron now. Okay, in order to balance iron, let's take a look at the reactant side because you can only add, you can never subtract. Okay, let's try to put 2 in this one, making iron in the reactant side 2, and then making also iodine 4. Okay, take a look again. You can see iron is now balanced, but iodine and chlorine are not. What we need to do now is proceed with adding coefficients. Again, as I've said, balancing equation is a trial and error process. So you just need to add and add. Okay. So for the iodine on the product side, since it's alone, okay, it's a diatomic atom, you only need to add 2 coefficients. Okay, meaning you have to multiply it. 2 now will become 4. Let's double check again. Reactant side, iron is 2. On the product side, the iron is also 2, making it balanced. Iodine is 4. Product side, iodine is also 4. But chlorine is it's still not balanced. What you need to do now is continue to add or to change the coefficient. Let's take a look at this one. We have to adjust on the reactant side because it's much lower than the one on the product side because we can only add. Okay, so what you need to do now is to try to change the coefficient in this chlorine on the reactant side. So let's try to make it 3. Okay, so now instead of having 2 chlorine, you have to multiply 3 by 2. This is now 6. Okay, do not afraid to change the coefficients if you think that your equation is still not balanced. Let's now check. On the reactant side, again, iron is already balanced. Both of them has 2. Same with iodine. Okay, same with iodine. We have 4 iodine on the product side and 4 iodine on the reactant side. On the next, on the chlorine, we have 6 on the reactant side and then we also have 6 on the product side, making our equation now balanced. Okay, so here are our coefficients. So we have 2 ferrous iodide and 3 chlorine. We also have 2 ferric chloride and 2 iodine. Okay, now our equation is now balanced. Okay, so we have here another example of a chemical equation. This will be our last example. So we have here aluminum plus ferric nitride will produce aluminum nitride and iron. Okay, so we'll proceed immediately with writing down the elements involved in each side. So we have here the reactant side and the product side. So on the reactant side, we have aluminum, we have iron, and nitrogen. Since nitrogen is again a diatomic compound, we'll be putting it as this way. And then for the product side, we have again aluminum, just the same elements. We have nitrogen and iron. Okay? Then we'll proceed with counting the quantity of each element for each side. So on the reactant side, we have 1 aluminum, we have 3 iron, we have 2 nitrogen, and then on the product side, we have 1 aluminum, we have 1 iron, and 1 nitrogen. So by simply looking at this table or listing, we can see that aluminum are balanced because we have 1 atom for the reactant side and 1 atom for the product side. However, for iron and nitrogen, they are not balanced. On the reactant side, we have 3 iron molecules, and on the product side, we only have 1. On the reactant side, we have 2 nitrogen molecules, and on the product side, we only have 1. Okay, so we'll proceed with adding coefficients to make this equation balanced. Okay, we'll be starting, of course, with iron. Okay, since on the reactant side we already have 3, we will be adjusting now the product side. Okay, as you can see here on the product side, iron is an element. It does not have a companion element, or it is not a compound. So you can simply add here 3. Okay, and this will make iron 3. Okay, now your iron is now balanced. Let's proceed with nitrogen. Same with iron, we will be adjusting, or we will be adding to the nitrogen on the product side, because nitrogen on the reactant side is already 2, so we have to add, okay, on the product side because we cannot subtract. But on the product side, nitrogen is with aluminum, meaning if you put a coefficient of 2, okay, if you put a coefficient of 2 in this compound, yes, nitrogen will be 2, but also aluminum, okay, because this is a coefficient, you have to distribute it to both of the elements included in the compound, okay. Now that nitrogen is balanced, let's check aluminum. As you can see, since aluminum is with nitrogen, the aluminum in the product side became 2, okay, making them not balanced with the reactant side. So you have to adjust the reactant side for aluminum much further. Okay? Similar to how ferrous or how iron was balanced, you can simply add 2 in this one because, as you can see, it's not a compound. You can simply add 2 on the other side. So this aluminum from 1, it will become 2. And then if you are to double check it, we can now have a balanced equation. The reactant side for aluminum has 2, and then the product side also has 2. The iron, both sides have 3, and nitrogen, both reactant and product side have 2. Okay, making our equation a balanced equation. Okay. So this is the last part, or the last example for balancing equation. There are more sample equations to be done after this part 1 of the module 1. This is to practice for you to practice, okay, balancing equations with different more examples, okay, in preparation for your quiz and for your graded activity.